Hi guys, in this video I'm going to show you some rules for differentiation, and these are like the basic rules for differentiation, and then I'm gonna do some examples using those rules, and so then you guys can see how to apply those rules. Alright, so let's talk about those rules. So for fx is equal to xn, if you have given a function in this form, so differentiation of that function will be you have to take the power into the front and minus 1 from the power. Okay, so that's the first rule that we're gonna talk about. And the constant function, so differentiation of a constant is always 0. I talked about this in my last video. The multiplication rule, if fx is equal to k is a constant, gx, and then you have like another function, so it's like 5 times x or something, x squared. So then you have to apply this rule. So the differentiation of that is equal to k is equal differentiation of the function is equal to k. So the constant doesn't change, and the differentiation of the function. That is the derivative of a number multiple is a multiple of the derivative. The sum is the same thing. If you have the function in the form of fx is equal to gx plus hx, so then the differentiation of this function is equal to differentiation of this plus this, which is self-explanatory, right? The difference is the same way as the sum. All right, so let's look at some examples. All right, let's see. Go to the next slide. All right, so in this one, let me get my pen. This color. Okay, so in here, for each of the following, find the derivative with respect to x. So they want us to do either they can give you a description like this, or they can give you dx. That's another way to write differentiation. d dx x 6x cubed minus 2x squared plus 3x minus 5, right? So we have to solve this, right? So let's say, so this is the first rule, right? We have a, oh, so this is actually the second rule, the third rule. We have a constant and then we have a function, right? So when we have a power, what we do is we take the power into the front. So this is going to be 6 times 3x 3 minus 1, right? And then we can apply the addition rule or the subtraction rule for all of this. So the second one is going to be 2 times 2x 2 minus 1, right, plus 3 times x to the power 1, so you have to take the 1, and then what happens to the x? 1 minus 1, x to the power 0 minus, so differentiation of a constant is 0 all the time. Every time differentiation of a constant is 0. So 6 times 3 is 18 x squared, 3 minus 1 is 2, and 2 times 2 is 4, and 2 minus 1 is 1, plus 3 times 1 is 3, and x to the power 1 minus 1, so the 1 minus 1 is 0, so x to the power 0 minus 0, right? And then we can simplify this a little bit more. So 18x squared minus 4x, right, plus x to the power 0 is 1, so it's plus 3. So this is going to be the answer for this question. So this is the answer for the differentiation. Derivative of this function respect to x. All right, then moving to the second example. All right, find for each of the following, find dy over dx. Right, they have given the function in the y form, so it says y is equal to 7, so they want us to find dy over dx of 7, but the differentiation of a constant, as you know, is equal to 0, so this is going to be 0. There is no difference. There is the because if you graph this for the further explanation, if you graph this is a y and x, this is in this graph for and somewhere 7, so this is just a line, right? There's no slope in this line. It's just a horizontal line, so there's no slope, so there's no derivative of a constant, so derivative of constant is 0. Okay, in this question they want us to find the differentiation of this fraction. So the best thing is to break up the fraction into two components and try to solve the fraction, so that we don't have to deal with the fraction anymore. That's one of the typical rule that we use when we do differentiation. So we can rewrite this as dy over dx is equal to 9x to the power 4 divided by x plus 3 squared is 9 over x, right? So this x cancels out, so this becomes x to the power 3, and we can take the other x to the numerator, right? So it's gonna end up being looking like this: 9x to the power 3 plus 9x to the power negative 1. When you take the x from the denominator to the numerator, it becomes negative 1. Okay, I hope that's clear for you guys. Alright, so to do the differentiation of this, we have to take the 3 into the front, so 3 times 9 is 27, and minus 1 from the fraction, so it becomes x squared, plus we have to take the power to the front, so it's become negative 1 times 9, so it's become negative 9, times we had to minus 1 from the fraction from the power, so we become negative 1 minus 1, so it becomes 27 x squared plus, so negative, positive and negative, so this becomes a negative 9, so let me erase the plus sign, so this becomes negative 9 x to the power negative 1 means negative 1 plus negative 1, so it becomes negative 2, or else in other words we can write it as 27 x squared minus 9 over x to the power squared. So this is going to be the final answer. Alright, thanks. For each of the following, find the derivative with respect to x. Okay, here it's not respect to x, it has to be respect to z, because there's no x's in this equation. So in the question they have given correctly, in the description I wrote it wrong. So derivative with respect to z, so this has to be respect to z, right? So let's do it. So take the 3 into the front here, so it's going to be 3 times 6 is 18, z squared minus 4 times 2 times 4 is 8, c to the power 1, and for the 9, for the 3, derivative of a constant is 0, so this is correct. So we do that, and the next one, for each of the following find the derivative of fx, thus find f derivative at 1. Okay, so we had derived this equation, differentiate this equation, and then we had to plug in 1, find the answer when it's equal to 1, right? When x is equal to 1. Okay, so let's find this, differentiate that. So we take the power to the front and minus 1 from the power. You take the power to the front. 3 times 3 is 9, minus 1 from the power. And okay, so this is the 1. So we can plug in 1 to the equation. So it's going to be x to the power 4 is, well, 1 to the power 4 is 1 minus 1 to the power squared is 1. So 5 minus 9 is negative 4. That's the answer for that. Let's move into the other one. For each of the following, find the derivative of fx, thus find f at 1. Right? So this has to be find the derivative of fc, because no, that's correct. Find the derivative of respect to x of the equation. Okay. Yeah. Respect to x of the equation. Let's do this. So dy dz is equal to, take the power to the front, so it's going to be 4 over 4 and minus 1 from the power, plus take power to the front, so it's going to be 3 times 3 is 9 and x to the power squared. So this is going to be 4 over 4 is 1, so x cubed plus 9x squared. And this is, let's plug in 1 here, so it's going to be 1 plus 9 times 1, so it's going to be 1 plus 9 is equal to 10. So answer is 10. Alright, I hope you guys understood the principle. It's very simple. These are like basic principles of differentiation. And yeah, if you have any questions or comments, please comment down below and subscribe to my channel. And yeah, I see you with another video with some other rules of differentiation and with some examples. Thank you.